VNBN vertical and short takeoff and landing capability has been pursued by military aviation programs across multiple decades, services, and nations. This video presents a complete reference-style catalog of every known military aircraft designed with true VTOL or operational STOVL capability. The scope includes experimental prototypes, limited production platforms, and aircraft that entered sustained operational service. This reference covers military VTOL and STOVL fixed-wing and tilt-rotor aircraft developed from the early Cold War period through the early 21st century. The catalog is organized chronologically by propulsion and lift generation concept, reflecting the technical evolution of vertical lift solutions. Rotary wing helicopters are excluded, as this overview is limited to aircraft that combine vertical lift with fixed-wing forward flight. The presentation is encyclopedic in structure and intended as a complete technical overview. Early VTOL experimental aircraft 1950S-1960S. Bell X-14 experimental VTOL research aircraft developed by Bell Aircraft for the United States Air Force and NASA. The aircraft served as a vertical takeoff and landing research platform. It used two turbojet engines with vectored exhaust for vertical lift and forward thrust. Its purpose was to evaluate controllability, transition flight, and pilot workload during VTOL operations. Ryan X-13 Vertijet experimental VTOL prototype designed by Ryan Aeronautical in the United States. Its role was to test tail-sitting VTOL concepts for interceptor aircraft. It launched vertically on its tail using a single turbojet engine. The program explored vertical launch feasibility without conventional runways. Convair X-FY-1 Pogo experimental VTOL fighter concept produced by Convair for the U.S. Navy. It evaluated tail-sitter VTOL operations from confined shipboard environments. The aircraft used a turboprop engine with contra-rotating propellers. The design investigated fleet air defense without aircraft carriers. Lockheed X-FV-1 Salmon experimental VTOL prototype developed by Lockheed in the United States. It served a similar role to the X-FY-1 in tail-sitter testing. The aircraft used a turboprop propulsion system. The project assessed vertical launch concepts for naval aviation. Thrust vector jet VTOL aircraft. Hawker Siddeley P-1127 experimental VTOL strike aircraft developed in the United Kingdom by Hawker Siddeley. It was intended as a lightweight VTOL ground attack aircraft. The aircraft featured a single Pegasus turbofan with 4 rotating exhaust nozzles. Its success established thrust vectoring as a viable VTOL solution. Hawker Siddeley Kestrel Faja, one evaluation VTOL aircraft built as a multinational evaluation platform. It served as a strike and close support test aircraft. The Pegasus engine allowed vertical and short takeoff capability. The program validated operational deployment concepts for VTOL jets. Hawker Siddeley Harrier GR-1 VTOL attack aircraft produced in the United Kingdom. Its primary role was close air support and battlefield interdiction. It used vectored thrust turbofan propulsion and short field basing. The aircraft enabled dispersed operations without prepared runways. McDonnell Douglas AV-8, a Harrier VTOL attack aircraft manufactured in the United States under license. It performed close air support for the U.S. Marine Corps. The aircraft retained vectored thrust propulsion. Its relevance was tied to expeditionary operations from austere locations. Boeing AV-8B Harrier II improved VTOL strike aircraft developed by Boeing and British Aerospace. It served as a multi-role ground attack aircraft. Upgrades included composite structures and improved aerodynamics. The design extended the operational life of VTOL jet concepts. Soviet and Warsaw Pact VTOL designs. Yakovlev Yak-36 experimental VTOL aircraft developed by the Yakovlev Design Bureau in the Soviet Union. Its role was VTOL feasibility testing. The aircraft used lift jets combined with the vectored thrust engine. It provided foundational data for future Soviet VTOL programs. Yakovlev Yak-38 Forger VTOL naval strike aircraft produced by Yakovlev for Soviet naval aviation. It operated from Kiev-class aircraft carriers. The aircraft used a main engine plus dedicated vertical lift engines. Its purpose was to provide organic fixed-wing aviation from small carriers. Yakovlev Yak-141 freestyle supersonic VTOL fighter prototype developed in the late Cold War period. Its role was fleet air defense and interceptor missions. The aircraft combined a swiveling exhaust nozzle with lift engines. The design demonstrated supersonic VTOL feasibility, lift fan, and hybrid VTOL systems. Lockheed Martin X-35B experimental STOVL demonstrator developed for the Joint Strike Fighter program. It demonstrated short takeoff and vertical landing capability. The aircraft used a shaft-driven lift fan system. Its success defined the production configuration for future aircraft. Lockheed Martin F-35B Lightning II STOVL multi-role fighter produced in the United States for Allied forces. Its role includes strike, reconnaissance, and air defense. The lift fan system enables vertical landing and short takeoff. The aircraft supports expeditionary basing and amphibious operations. Tilt-rotor VTOL aircraft. Bell XV-3 experimental tilt-rotor aircraft developed by Bell Helicopter in the United States. Its role was tilt-rotor concept validation. The aircraft transitioned between helicopter and airplane modes. The project demonstrated aerodynamic feasibility of tilt-rotor systems. Bell XV-15 experimental tilt-rotor demonstrator produced by Bell in cooperation with NASA. It served as a research platform for operational tilt-rotor performance. The aircraft featured rotating engine nacelles. Its data directly supported later operational designs. Bell Boeing V-22 Osprey operational tilt-rotor transport manufactured by Bell and Boeing. Its role is troop transport, logistics, and special operation support. The aircraft combines vertical lift with turboprop cruise speed. Its relevance lies in extended range VTOL transport capability. Dedicated VTOL research platforms. Dornier Do-31 VTOL transport prototype developed in West Germany. Its role was vertical takeoff tactical airlift. The aircraft used multiple lift jets and cruise engines. The program explored VTOL logistics without runways. Uer VJ-101 experimental supersonic VTOL fighter developed by a German consortium. It aimed to combine VTOL with supersonic performance. The design used tilting engine pods. The aircraft demonstrated high-speed VTOL transitions. Dassault Mirage EV experimental VTOL strike aircraft developed in France. Its role was VTOL nuclear strike capability. The aircraft used 8 lift jets and 1 main engine. The complexity limited operational practicality. Modern and unmanned VTOL fixed-wing systems. Northrop Grumman turned VTOL UAV concept developed in the United States. It was intended for shipboard intelligence and strike support. The design combined tilt-wing propulsion with unmanned operation. The concept addressed carrier-based unmanned VTOL needs. Boeing Phantom Swift experimental VTOL wave developed for advanced research programs. Its role was autonomous VTOL flight testing. The aircraft used ducted fan propulsion. It explored reduced acoustic and radar signatures. As VTOL aircraft evolved, designs shifted from pure experimental platforms to operationally sustainable systems. Early liftjet and tail-sitter concepts were replaced by thrust vectoring and tilt-rotor architectures. These transitions reflect the need for reduced complexity, increased payload, and improved reliability. This reference has cataloged every known military VTOL and STOVL fixed-wing aircraft, spanning experimental prototypes, limited production systems, and active service platforms. The overview reflects the full technical spectrum of vertical lift solutions developed for military aviation. For additional reference-style military and aerospace catalogs, viewers may subscribe for continued coverage.